right, thank you guys so much for coming out. It's really awesome to be here. The amount of content I'm going to try and get to is a little ambitious for 45 minutes, so I'm going to try to get through things pretty quickly. If I don't get to questions at the end, I'll be around right after this or the rest of the week, so feel free to hit me up. But real quick, my name is Greg Shackles. I'm a senior engineer for Olo up in New York City. Here's my contact information, so you can reach me easily on email or Twitter, or I'll be around. And I'll tweet the links. These slides are already available, so are the samples that I'll do later, and I'll tweet about all that. But for now, I'll just get to content. So, it's actually really awesome to see this many people interested in this. This is cool. But I want to start off with a little story, and it should sound, it'll probably be somewhat familiar for, I'm assuming everyone here is a developer, so this is kind of a familiar tale. And it all starts with, you have an idea, you have the next big thing, you're convinced you're going to ship this, it's going to be awesome, it's going to make you millions, and you're going to start swimming Scrooge McDuck style through money. We all have it, and that's how it works, right? So then what do? You have it, you assemble the team, or maybe you just start working nights and weekends, and you just build, and you ship it, and maybe it's successful, and customers just start throwing money at you, and you're this shy of that pool of money that you could swim through. But it takes a little more than that to get there. But until then, things are pretty awesome. You're looking pretty good, your customers love you, you're getting great reviews in the App Store, and you go out for some drinks and you have fun, and things are good. It's a good time for your business. But you have to move on from there. So what happens after that? The customer requests start coming in, you have new feature ideas that you want to develop, so you just start slinging out new builds. The mobile world moves really, really quickly, so it's important to be able to iterate really quickly, and we throw apps out there. But we're all developers again, so we know that it kind of makes things complicated, and if you start moving really quickly and not worrying about it, you'll end up with code that basically looks like this. Maybe you have some spaghetti code, maybe you end up with a piece of your system that you're really afraid to touch, or maybe you just start having bugs that start creeping in because you touched a screen over here and you didn't realize that you were actually impacting some piece of the system over here and you didn't catch it during testing. So not only does this suck as a developer to have to work with, but customers don't exactly like it either. So they're going to start coming after you, and they're going to start sending you complaints. They're going to start leaving bad feedback in the store. It's the beautiful thing about app stores. Mobile is awesome, but customers get the ability to leave you feedback in the most public and humiliating of ways. It's not just a private email. You're lucky if it's a private email, but it's probably going to be a review, probably a little more harsh than this one. And if you get the reference, thank you. But you could probably tell what movie I was watching when I drafted these slides as well. But anyway, through the App Store, the App Store gives customers this megaphone for largely bad reviews. There are a lot of good reviews in there too, but if you piss off a user, they're far more quicker to just leave you a bad review than they are. If they're happy, then they're probably not thinking about it, and you're just getting out of their way, and you don't necessarily get that good review unless you start asking for it. And this makes us sad. And we don't want to be sad, because now we're sad, now the customers are sad, our code is even sad, if that's important to you. So what we really want to do is, just not be sad like Ukianu here. We could do better than that, and that's kind of where I want to get to with this talk. How can we as app developers and product developers really, because it just comes down to shipping products, how can we deliver continuous awesomeness both for us and the client and kind of keep moving and iterating without having to worry so much about all of the sad slides and the bad reviews from before? So that's where continuous integration comes into play. And just as a caveat up front, I'm using the term continuous integration here pretty loosely. There's a lot of different definitions out there, and then it expands into things like continuous deployment, continuous delivery. I'm going to try and talk about basically everything here. So a better title of the talk might have been how to automate all the things, because you don't want to be doing any manual work or that you don't really have to. It just gets in the way, and you want to be having your tools do all the work for you. So the more you can make your tools kind of fit together and work together, the better off we're going to be. So just a quick show of hands, how many people are already using CI of some sort here? Okay, that's a lot of people, which is good, because then I can move really quickly through this slide. How many, I should probably just do the inverse, how many aren't? Cool. How many of you that are doing it with mobile already? A decent amount of you, but hopefully next year when I come back here, there's a lot more hands up for that question, or that I don't have to give this talk again. But so what the basics of what CI is so you have a bunch of developers there, they're committing code into some central repository, Git, Mercurial, whatever it is that you're using. You're checking code into somewhere. And what happens then is you have a continuous integration server, sees that that change happened, and then it sends off some jobs over to a CI agent that's connected to it. And these jobs can be anything from, at the very basics, running a build for all of your apps and saying, oh, well, you actually have a compilation error over here, you should go fix that. Or you can run unit tests, or you can run integration tests and UI tests. One of the big themes that we've seen today is UI test and test cloud, and you can tie all of these things together into your CI builds and just have everything work as one harmonious system. And it goes even further than just tooling and things like that. If you're running unit tests, then you can get code coverage reports and watch how those trend over time. Or you can look at static analysis tools to see how complex a piece of code is and watch these numbers over time. So really, these just become really important tools to assess the pulse and the state of your project. And then, as I mentioned before, delivery comes into this as well. So the more you can tie in delivering, say, an app out to test flight or preparing everything to deploy out to iTunes Connect or Google Play, the more you can automate around that, the quicker you can be able to iterate and the safer you'll be. I'm going to be focusing, well, my examples will focus on Team City today, but everything is going to apply basically across the board for any option that you have out there. These are a few different CI options that you can do. Really, CI, when you boil it down, is basically just running things from the command line. So anything you can do from the command line, you can run as a headless process on a CI server and just kind of make it happen. So a lot of what you'll see for the next bunch of slides does boil down to just command line things. And the command lines will apply regardless of which version or which brand you're using to execute them. And for delivery, you can use TestFlight as a pretty great option for doing iOS delivery. You can no longer use them for Android since Apple bought them. Shocking. But you can, Hockey app is another good option that's cross-platform as well, or there's a whole host of other ones. Everything out there these days has an API that you can hook into, so everything is fair game for just automating. Just automate everything. So what I want to get into is some specifics of how you do CI with Xamarin apps. And again, this boils down to, at least at the first stage, what are the commands that you need to run? And I'm going to show a bunch of commands on the slides here. Commands in themselves aren't all that interesting, so I'm going to try and go quickly so I can actually show cool stuff. But I wanted to at least have them here to show that they're really easy to execute, and they're just kind of sitting there waiting for you. But first, you do need to set up your build agent. So setting up a build agent, aside from the agent software, is just like setting up a normal development environment for yourself. So you need a machine to run it on. I recommend using an OS X install. You can use Windows if you want, mainly for Android stuff, but you're going to need some sort of OS X install for your iOS builds. So a Mac Mini works really well. At work, we just have a Mac Mini sitting in the office that's running all of our CI processes for the mobile side of things. And it works really well. You don't need a big powerhouse of the little garbage can Macs that cost $8,000 or something to run this stuff. It's really, really simple. So a little Mac Mini will do the trick. And then you have to install all the same tools that you would need on a normal development environment. So there's the platform SDKs for Xcode and Google. You'll have to install the Xamarin tools. And Xamarin's installer takes care of a lot of that, especially on the Android side, of course. So it makes it pretty easy to get going. And then you have to install the agent software for whichever CI service that you decide to go with. And you could always kind of roll your own as well. These are, again, just command lines. But for most of the CI agents out there, installation, even on the server side, amounts to basically copying a folder from the install file out to wherever it's going to run, and you're almost all the way there. So it's really, really easy to get going. And an iOS build, so Xamarin Studio ships with a little tool, whether you knew it or not, called MD tool that lives inside the app folder that wherever you have Xamarin Studio installed into. The default path is up here. And you can basically call that, you just say MD tool build, point it at your solution or your project, and you can give it the configuration that you want to compile for. So that could be App Store, debug, iPhone Simulator, all the same stuff that you would have done right through Xamarin Studio or Visual Studio, you can target right through here. And packaging is just as easy. What you need to actually submit out to Apple if you want to submit your app is just a zipped version of the .app file. So you can use a command line or any zip library you want, just zip it up, and that's exactly the file that you would submit out to the Xcode application loader. So there's really not much work you can do there, and you can kind of do all that automatically and just end up with the exact file you need. On the Android side, it's almost as easy. So you can use xbuild or msbuild depending on what environment you're on. The arguments are going to be the same either way, and you just say build, give it the configuration, point it at your solution file, and now you know if your app compiles or not. And if you want to package, there are a couple extra steps that you have to do because that's how Android works. So you have to first say package for Android, again using xbuild, point it at your project file instead of your solution file, and it'll create your unsigned Android package file, the APK, that you can then use for the next steps. What you'll have to do, you kind of just take that APK, you run it through an executable called jar signer that signs it with whatever key store you want to use to distribute the app, and you give it all that information. And then you have to do another command called zip align on it. Again, these are kind of boring commands on their own, but it's not that much work to just set up a script to do this stuff, and you can have fully automated builds for iOS and for Android. And then package restore is the same way. So if you open your solution file and you're missing some Xamarin components or you're missing NuGet packages, Visual Studio or Xamarin Studio is going to restore those for you automatically, but that doesn't happen automatically from the command line. But thankfully, both NuGet and Xamarin component also offer restore ability. So you just have to run NuGet.exe, say restore for the solution file. It'll go pull in whatever you need. So you just run this as part of your build script. And the same applies to the Xamarin component.exe that you can get with the component tools from their website. And then if you're running on Windows, you obviously don't need the mono prefix here, but mono is able to run both of these executables perfectly. So if you're on OS 10, you just say mono, then the exe, and it'll run as expected. And then hopefully you guys have been paying attention to the really awesome UI test coming out of this Evolve. There's some good sessions earlier and even some more later that are definitely worth checking out. And you can script all of this stuff as well. So the Xamarin UI test library actually just runs the normal NUnit tests. So any NUnit runner that you have out there, it can be what's in Visual Studio or Xamarin Studio or ReSharper or whatever you want to use, or a command line based one like the example here. Any of those can just take a test project from UI test and run it through the test runner. So that's just as easy as well. But when you get into the UI side of things, there's one thing that I do want to call out, which is that by default, your CI agent is going to be running in kind of a background mode where OS 10 isn't going to just allow it to start touching things in your UI. Normally you don't want your background processes messing with the user interface that some users actually interacting with. In the case of your CI build, if you're running these tests that actually need to tap through the UI, you do want that. But it's really, really easy to actually set that up. And this example is for, it lists the plist file for TeamCity, but it would be the same kind of plist for whatever service that you actually want to go with. The plist is just the app way of doing things. It's not TeamCity specific. So you set the username to the user that logs in, that you're logging in as on the machine. And if you copy this file into root library launch agents, the next time you restart the machine, the service is going to start up in a context where it actually can touch the UI. So all of your UI tests can just run without having to mess with it at all in the future. And Test Cloud is also just as easy to submit. You just run the Test Cloud exe, you point it at your app file and your test file and give it all the information about what devices you want to run it on. And then you can also tell it to pump out NUnit results into an XML file, which you can pull into your CI build as actual test results. And I'll show some examples of that later. But it makes it so you can actually see, not only can you get an email when a build finishes or go into the really nice web UI, but these tests can also just show up right in your build results, and you can see passes and fails and everything right in there. So it really does help to tie all of your different pieces together. And then, so those are, the basic commands that you need to get going, but there are kind of nicer ways to do things. So I did want to call out a library that I've become a really, really big fan of called Fake, which is, like most things that end in AKE, it's a build system. If you haven't guessed from the F, this one is in F#. So you get to take advantage of F# and even C# libraries or anything like that, NuGet packages from your build scripts really easily. You get a really nice DSL that's built in F#, makes it really clear to define targets and things like that. And it's also cross-platform. So you can define build scripts that'll run on Windows or Mac, which is really, really nice for all of us cross-platform developers out there. And this isn't limited to iOS or Android, too. They have all sorts of stuff built in, or you can build your own extensions. But this is an example of what a main build script might look like. So you can say, I have a couple different things that I might want to build for my app. I might want to say, just build the iOS app and make sure it compiles. So that's that first one there. Maybe I want to do an ad hoc build so that I can upload it to test flight. So then I have a third step there for upload to test flight. And then at the bottom, you even have you're given a pretty nice syntax for defining dependencies between targets. So there it says, well, if I say run the iOS test flight build, then make sure that the ad hoc one runs first because it depends on it. So all that's to say, it's just a really nice build system worth checking out. And it does ship in the box with a whole bunch of nice helpers and classes and methods that'll make it really nice and concise to script all these things together. So I mentioned earlier that if you build your APK file, you can publish it as an artifact in TeamCity, for example. You don't have to actually worry about how to do that in TeamCity. Fake ships with a helper built in that you just say publish artifact to this zip file, and that zip file will show up in your build when you go look at it later. Or you can send the NUnit test report from your test cloud run. So after your test cloud run is done, you just publish that'll pull the XML file in, and they'll show up like any other NUnit test results in your build. So you don't have to, again, worry about how any of that works. It's really nice and readable. Test flight, there's also one in the box for that. So if you compile your app, you could say, push this out to test flight, you give it your app token and your team token, and you're good to go. And what we actually do at work is every time we deploy to test flight, we push a message using HipChat into our mobile room. So what we did is we published our HipChat notification helper as well. So you could say, publish this message to this particular room and with this text and color, and you'll get a nice message right in your HipChat room if you're using that. And it just kind of, again, the more you can tie all these tools together using the APIs that are available to you, the more cohesive of a system and compelling of a system it becomes. But we actually didn't stop at building the HipChat notification helper. We also published a few that are Xamarin helpers as well. And these helpers aren't really rocket science. They're shims around the commands that we talked about earlier. So they were pretty easy to get going. But if you want to use Fake and you don't want to have to worry about this stuff, we did publish a few helpers to do that. So if you want to do a component restore, or you want to do an iOS build without having to worry about remembering how MD-Tools it works and the parameters for it, or you want to do an Android package process, so you could say, after you do your MS build step, you call Android package, you pipe the result of that into signed and align, and then you'll end up with a file info object that has your signed and aligned APK, and you can just say, well, publish that right into TeamCity. So you have, again, and it's thanks to the niceness of F# and the pipelining and things like that, you can end up with a really readable build script, which is not something that you could say about most build languages out there, to be nice about it. So I do want to talk real quick about, just to use us as a little case study of how we at Olo, the company I work for, we tie all these tools together and we work as a development team to kind of do all this stuff. So what we are at Olo is we're a white label online ordering platform for restaurant chains. And you don't need to worry about the specifics of that because that's not what we're here for. But what it boils down to in this context is we put out iOS apps and Android apps, among a bunch of other things. And we put those out white labeled for a whole bunch of different brands in our system. These are just a handful of brands, some of which you might recognize, but we have a lot more in the system. But when you're dealing with this, releasing one app manually to the App Store is a royal pain. And doing it across 10 or 20 or 50 or however many that we have to do, it's just impossible. Like, we would have our engineers spending all of our time pushing to test flight or pushing to the App Store or doing release notes and things like that. So we needed a lot of automation in place to enable non-engineers to be able to work with pushing to test flight or pushing to the App Store and things like that. But then the other thing that I realized I forgot to mention about CI that's important earlier is that it also takes away a lot of the works on my machine thing that can happen. I mean, a lot of us are probably web developers in the past, and we all agreed a long time ago that it's not a good idea to just do a build and then take your bin file and then upload that to your server. Like, we all kind of agreed that that's a pretty bad idea. And we agreed on that a long time ago. But when it came to coming back to mobile, like, that became like all the rage again. Like, it was kind of okay to just say, oh, well, open up Xamarin Studio, pick App Store, and then upload to the App Store, and that's how you do your app deployment. But now that build has everything that's on your machine. It's susceptible to everything in your environment. Maybe you accidentally or not accidentally switch to the alpha channel, and there is kind of an alpha bug in there. And it can like hamstring you as a developer and also just let things creep into your system that are unpredictable. So pushing all these builds out to a nice predictable environment goes a long way to let you do what you need with your local tools without impacting the builds, but also the next time you bring someone into your project, there's a much better chance that the system actually builds like it's supposed to without a whole lot of extra configuration, because you have at least 2 environments now that this runs in. So from a branching strategy, and again, I'm using a very loose term of CI in some of these, but they all kind of tie together in my mind. But we're using Git and GitHub as our source control mechanism. We use feature branches for everything that we're working on to keep the kind of main branch stable. But then every single branch that we have is building every test that we have in our system. Every branch can be deployed to test flight with the click of a button, or deployed to test cloud with the click of a button. We use pull requests. So the more you can use these tools to your advantage and just tie it all together, it really helps kind of bring a team together and get this process really smooth. And on the test front, I mean, it's one of the big promises of Xamarin, and it really does hold true, is that you can share a lot of code across platforms, and it becomes really, really testable. So in our system, we have, at this point, it was a little under 300. It's over that now. I should have updated the screenshot before getting up here, I suppose. But we have, call it 400 unit tests that run on every branch, on every check-in. And it's really testing the core underlying flow of our app, the real business logic, the behavior. So we'll know really quickly if we broke something really core there. But then, and that runs, and that's really nice, but there's still the UI component. So like I mentioned before, we have the ability to say, we can run the UI tests on our locally, or we can run the UI tests on our CI agent through the simulator or the Android emulator, or the Xamarin Android player now, which is much nicer. Or we can push those out to test cloud. So again, enabling all these things goes a long way to just make sure that we have a really rock solid system. Because once a bug is out there, you can't just pull an app out of the store really easily. It's going to sit there getting bad reviews until you find the bug, you fix the bug, you get the update out there, approved by Apple, and then you wait for the user to update the app. And in the meantime, they probably had at least a couple weeks of a pretty bad time in your app. And you'll be lucky if they come back sometimes. So using all these things together goes a long way. And I mentioned that it's really, really easy for us to do deployment and distribution. So we have kind of one-click deploys out to these different environments. So I could say, create a test flight build for iOS. I can say, deploy it, the Wingstop app in this example, to Olo's live environment. Or we could also specify the development environment or the staging environment, depending on where we want to do our testing to. But the point is, like, that all ends up becoming configuration, and we can do whatever we need. And then when it's done, we'll get a little notification in our HIP chat room, and we're good to go. And our QA guys, or whoever, maybe our salespeople or account management, whoever needs to have access to this stuff can easily get it without having to go bug an engineer about it. And then the last point I want to make in slides before jumping into to demos with whatever time I actually have left, which I hope is enough, is monitoring is a really, really important part of the piece. And obviously with Xamarin Insights being announced this morning at the keynote, but beyond that, like for me and the way that we work is continuous doesn't end at it hitting an app store. It just doesn't end, period. So you need to know who's in your app, what they're using, what errors they're hitting, what problems they're hitting. Maybe they're not even using a feature that you think that they're using, or maybe that's because it's not useful, or maybe that's because there's it's not exposed in a useful way. But if you're not monitoring for these things and keeping an eye on it, you're just not going to know what's happening in your app. And these are, people treat mobile apps like a part of their normal workflow in their lives. So it's really important to know if they're hitting problems or how they're behaving in your app. And these are just a few examples of what we're using at Olo, actually, to do a lot of monitoring. So, HipChat, we're using Raygun, Insights, Analytics, and PagerDuty is another interesting one where it's kind of an API to an on-call service. So if something escalates that seems really, really important, we have the ability to say, well, push this into the on-call mechanism, and it'll call up someone or send a text message or an email or something like that. But again, it's just use all the tools at your disposal to tie everything together and just let you know what's happening. Like we're all very busy. Mobile development it's a busy space, and if you're relying on having to manually go in and look at the 18 dashboards that you have that kind of say what's going on in your app, then you're probably not going to see what's happening. So the more that your tools can push out to you what's really going on, problems that happen, or even just letting you know that a whole bunch of people are in your app and you're not hitting errors, that'll make for a pretty good weekend if you're going into one and you're not worried about it. So the more you can just understand what's happening in your app, the better off both you and your users are going to be. So I do want to show a demo here. Let me see, how did I do on time? Okay, I'm going to go very, very quickly. I'll go to, that's actually the fastest I've ever gotten through this. That's amazing. So I have the sample that I put together. It's, if you've seen the Xamarin Forms tip calc example, basically what I did is I forked that, added a couple little things to make it testable, and then I added some unit tests in there. I added some UI tests and test cloud tests to that, and set up a sample that's available on GitHub right now. These slides are also up in my my speaker deck account. But that shows just how you can use Fake and all these things to do Android and iOS builds and packaging and test cloud deploys and all that kind of stuff. So I'll show that off a little bit now. So if I jump into, I'll jump into Team City first here. So you can see I have, I'll minimize a few of these things. Everyone can read that okay, right? I'm going to take silence as a yes. Cool. So we have, say, there's the core. So this is the shared project that applies to both iOS and for Android. So there's 6 unit tests here that I had added. You can see that on every build they pass. But let's make this more interesting and kind of show how this works in practice. So I'm going to go into here, and I'm going to open the build file, and I'm going to make a really important change, like adding an extra space. So if I come in here, I say, I can push that out to my Git server here. So that got pushed out. And what's going to happen now is that the Team City install I have here is going to pick that up and start running through all the different builds in my system. And the length of time between that, I mean, it can take sometimes 30 seconds or so to pick it up, but then it'll kind of start going through. But what it's going to do is it's going to start running through. First, it's going to run the core tests here. Then it's going to run, if that passes, it'll run the iOS and Android app builds. And if those pass, it'll run the UI test project. And then there's also UI test test cloud ones here that are kind of a manual build for right now. But you can see, and I also want to show, so I have the file I pulled up before, made that big change to, is the fake build file here. So I've got a couple different configurations here, or targets that you can run under. So I have my core builds, my core tests, iOS build, ad hoc. You can see there's really not a whole lot of code required here to get going. iOS prepare for App Store, UI tests, test cloud. It's just kind of boilerplate code using a lot of the helpers that I talked about earlier, and some of the command line stuff for test cloud and UI test and whatnot. But the idea is that everything that a build server or my CI server is going to need to do, it's contained inside this file. And you can kind of go a few different directions with that. You can, like CI servers usually, especially Team City included, has built-in steps for things like MS build or built-in steps for things like NUnit. But personally, once I start building out a big system like this, I really like to just have everything be just self-contained within my build scripts. And then what that enables you to do is that all this stuff is runnable locally as well. So you can test all your scripts locally. I can run my UI tests locally with the same exact command that the Team City agent is going to run, and it helps keeps the environments in sync there as well. So you can see what happened here is my core project went through, my test passed, and now it's building the iOS, or the Android app. And it's got, let's see, and there's one queued here for the iOS app. So I'm going to let that go for a minute, and I'm going to go show like just what it's like to run these from the command line. So if I clear this out, if I said build, and let's run the UI tests locally for Android. So if I pull up the Android emulator here, or the Android player, I have to get used to saying that now, and I say Android UI tests. What that's going to do is, first it's checking, my script is checking that fake is installed via NuGet, and it'll pull it in if it's not. In this case, it's going to find it. And it's going to build the Android app due to the dependencies specified in that build file. And then it's going to build the UI tests and push them out to this Android player right here. And the one downside of CI talks is that watching builds isn't entirely interesting, and I apologize for any of that I make you do. But hopefully, it's all worth it in the end for you guys. And while that's going, so you can see the UI tests are running right down here now for iOS. And then now it's signing the Android build with the key store for UI test here. And if I catch it really quickly, I could probably see, you can see this is my Team City agent here running in a VM. And in a real environment, I'd highly recommend not using a VM, but it's kind of for demo purposes. But you can see it's running through, on the left there, it's running through the UI test on the build agent. And on the right, it just ran the UI test locally for Android. So this stuff works in both environments. And you can see at the end here, you get the build report that you would expect. And then if I come in here and I say, so I want to go into the UI test local here, and under tests, you could see that it ran the tip step here. And then what you can also do is, so if this is all finished building now, I'm going to get a little gutsy because I don't know what my internet connection is like, and I'm going to try and do a test cloud run. So this is kind of similar to what it would be at work. If we decide, okay, we're at a point where we want to run a test cloud run, we do it on demand. You can do it whatever makes sense for your particular process. I'm just going to say, let's kick off an Android run for test cloud. And while that's going, I'm going to show an example of what it looked like earlier, because that could take a few minutes. But you can see that the tests here show up as different NUnit tests in the system. So they report as normal NUnit tests. You could see that I only wrote one UI test in this case. It ran across 6 different devices. So you could see the calculate tip test passed for the Galaxy S4, the S5, what have you. So you'll get those for all the devices that you pick in Test Cloud for running your test under. And if I check back here, and if you haven't run the Test Cloud from a command line before, if I skip to the bottom, you'll get kind of, it's still doing the build here, but you'll get feedback, the same kind of feedback that you would get in the UI. If you're in Test Cloud, you'll get that feedback in the build. So if you're watching the build right here, you'll see running on 5 devices or waiting for devices and things like that. So you get real time if you're watching the dashboard there as well. So let's see. So you have all that stuff, and then again, while that's running, I also have these package steps here. And now I actually tied up my build server with this one. So I'll show an example of a past run, but you can see that I have the package for App Store step here, and there's a little artifacts drop down here. And I can actually jump into this and look at artifacts. And you'll see that the iOS package for App Store artifacts list has a zip file in it. And that's the zip file that I was talking about earlier that you can just submit straight to Apple when you want to send out your app. So the key here is that we actually send our account management team into here, or you can take this file and put it somewhere more centralized. But then it doesn't need to be an engineer at this point that submits your app out to the store. Someone else can write all the release notes and check all the dumb little boxes that you need to do to submit it to the store. And your system is just taking care of all the compilation and packaging and all these different code level details that you need. So it just makes it a whole lot nicer. And then the same is true here for Android. So if I look here, you can see it has a signed and aligned APK that's available for download as the artifact, and you could take that and you could drop that into your Android player if you want to do testing. You can push that out to you do staged rollouts or a full deploy through Google Play. Like, it's really up to you at that point, but the system is all kind of there. And you can see, so now it's testing, there's 1 running, there's 5 queued up, and if we go into Test Cloud over here, and I look at the Android build, you'll see the same kind of information here. So that's actually out in Test Cloud, running in that cool device lab that you might have seen in one of the sessions earlier today. Not making quite as much noise as that one was, but I hope not. But it's running out there, and you're getting results in real time, reporting back to your build, and then once it's done, so now they're all running now. But once it's done, you'll get those unit test reports, and you're kind of good to go there. So then I can also show, just to prove that we are actually using it. So let's just say, so this is one of our brands, one of our clients at work, and we run their stuff through Test Cloud and as well as some other brands. And this one right here isn't a vast example of like really deep tests, but you can see that at least just in this case, we're doing some basic smoke tests. We've had more since this one was put in place. But basic smoke tests of the app, like so you load the app, you want to test that we can still log in and out of the system, or we want to search for a restaurant and start ordering food and that kind of thing, because those are the core behaviors of our platform. And we want to test those across as many devices as we can. So if I come here, you could see, it can just step through, a logging in use case. And we take screenshots at every kind of step of the way so that if something does go wrong, right here you could see that you're logged in. And if something did go wrong, you could see what the state of the app was at that point. So it's totally up to you to decide how you get value out of this. But the tools are really there to just make it super easy to tie all this stuff together. And that actually finished. So I'm glad my internet stayed up. That's pretty sweet. So then, actually, I think that covered a lot of what I wanted to do. I guess with people in front of me, I didn't let myself get sidetracked. But are there any questions? I mean, you do need to keep it up to date, kind of the same kind of way you would keep your development environment up to date. To me, like, that's not such a bad thing. And I mean, sometimes it could be a pain. It's like, okay, now Xcode 6 is out. Now I need to upgrade my CI server to have all that stuff on it. But the benefit is that you don't need to make that move until you've already vetted that process on your development machines too. So you don't have to like risk your build environment to make sure that you work with the Xcode 6 tools. You could test all that stuff, vet it locally, and then you'll have to install all those updates over on your CI agent, kind of once you're ready to make that move at a system level. And I'm actually just going to put up this in the meantime, which has contact information and stuff. But yeah, I have thought about that. Right now, we just automate that through non-engineers manually doing that, which isn't perfect automation, but it works for our team. I mean, you would have to do some sort of just like web scraping type automation if you want to do that. I haven't seen any like real way to, like Apple has no APIs for doing any of that. Google doesn't really either. So right now we basically just document how iTunes Connect works and the different things that you need to do, because it's pretty cookie cutter each time that you need to do something. And we just give our account management team or whoever needs access, developer accounts within our system, which is a little bit of a pain, but it saves us a lot of time in the end. But I mean, in theory, you could just use web scrapers and start filling out forms through scripts if you wanted to kind of do that, but we haven't. I should probably repeat the question. The question was whether we're re-signing builds between QA environment and the live environment app submission. And for us, that kind of depends on which platform we're talking about. So in the case of Android, you can actually just take that same signed APK and install it wherever you want. In the case of Apple, they make it really difficult to sideload any app that you want, so you need to sign it with the right provisioning profiles and all of that kind of stuff, which I'm guessing is where your question is stemming from. So in that case, you can't really test the exact same binary between QA and your live environment, which actually, it lends itself to the point I was trying to make earlier, where it's really important to set up these tools to do all this stuff for you. Because in the past, I used to actually worry a lot about that, where, okay, well, a couple weeks have gone by maybe since I prepared this, this ad hoc build and sent it out to test flight, and my machine has changed since then, or maybe I changed the version of Xamarin or something. But if you're doing all of this stuff through your CI environment, and that's a much more stable environment, or at least if you're making changes, it's a much more deliberate change or a systemic change. There's a lot less that you need to worry about changing in between there. So we haven't actually run into problems because of it. But before we had the CI stuff set up, I used to be super nervous about every app submission. So at least this takes away a lot of that worry for us. Still have a few minutes. Anyone?
I do have a question about licensing, though. What's the appropriate way to do this with Xamarin? Because we do have this set up on TeamCity also, but we're using like one of our activations for a developer to do it. We signed the agreement and everything, but I feel like there's a better way to do that, but it was never made entirely clear.
So I mean, and I can't speak officially for Xamarin, so I have no authority on this, but everything I've always been told is that it's fine to just use an activation from one of your developer accounts. And it kind of seems like if you run out of activations and you just need one for CI, you could probably ask nicely and make it happen. Hopefully they don't come after me for hinting that might be a possibility. But basically, like our CI at Olo, our agent that's running this stuff is just using an activation from my personal developer account on Xamarin. So you could just use one of your activations there. The question was, if you're using Jenkins instead of TeamCity, does the step that I mentioned for editing the plist and the launch agent stuff still apply? And that's really just an OS 10 thing, and how OS 10 allows things to access the UI and sets permissions and things like that. So Jenkins would have its own plist that probably looks pretty similar to the TeamCity one, and you would want to follow the same steps there, yeah. Because if you don't have access to the UI, you're not going to be able to, for one, you're not going to be able to touch the simulator or the emulator, but you also won't be able to do things like access the keychain if you want to do signing of your apps and stuff as well. So that's definitely something you'd want to do. Was there another question over? Yes? No? All right, I think that's it then. But thank you so much.